We're being warned by researchers that something strange is going on in the sun, and it's already having an effect on us. If we are to protect our near-death in our near-death planet, we have to act. But our sun is also a furnace of destruction, and could plunge our civilization into infinite death with a single powerful solar storm. Now, researchers are trying frantically to solve the inevitable. Without our star, we wouldn't exist. Without the sun, there would be no heat, no light, and the cosmic radiation would probably kill us all, transforming our globe into a grim and empty wasteland. A mantle of high-temperature plasma reliably sheaths us from the radiation of interstellar space. Never rusty, it is continuously supplied to our midst by constant delivery into space of plasma from the sun. These heat and light make our planet warm enough that we have both heat and light, which allows plants to grow and also allows us all to live here and be warm. Just a bit closer to the sun, things look very different, and Mercury would not have life, and further from the sun, where it's dark and cold, our food base would not survive. If it is in the right proportion for a planet, and that planet has a protective atmosphere, the sun is a giver of life. However, the sun can also destroy, especially if it has too much of its protective radiation. Things could become chaos on Earth. We know a solar storm is coming, and it's a bad one. The one we're not sure about yet is the one we can't even begin to estimate. This is the primary reason we need to know more about our star. And that's why NASA set up the Solar Dynamics Observatory. Are we near the solar apocalypse? We don't realize, as few of us, as many simple things. We depend constantly on the sun's influence both at night and during the day. 10,000 of these powerful furnaces fire charged streams of particles into space around the clock. And our Earth is used to spending time with these solar winds, and it's even beneficial. A little sun is good for getting a tan or relaxing, but too much is bad news. The Earth's huge magnetic field normally keeps a good grip on the solar winds, trapping the particles up in the upper atmosphere, and we can occasionally see those particles as auroras. But that doesn't always work, and sometimes extreme ultraviolet light makes its way into deeper layers of the atmosphere. They would then send sparks up from power grids, or your cell phone would announce a blackout out of nowhere. Does that sound crazy to you? In 1859, however, that's what happened. The last devastating solar storm paralyzing electrical systems and the telegraph network. We are sure this is not the end. Sure, this next storm of this magnitude will change our civilization forever. It's coming. Consider stepping out into the yard when it's morning and looking and seeing bright lights in the sky that don't look like they belong there. Purple auroras were seen in the middle of the USA in 1859. Next, you attempt to switch on an electrical appliance, but it will not work. Your fridge has already stopped humming. When you pick up your phone to see what has happened, a few sparks strike you. You look outside and you can recognize that the people walking down the street are looking up at the sky. It's everywhere. Same story. It's the power's gone, phones don't work, no internet, nothing in general. No one but a bunch of people knows what's happening. Perhaps your administration's vehicles are blaring their loudspeakers down the streets telling you to control yourself. If you need to go to work, there's nothing you can do because computers, streetcars, plus many other things will just cease to function. Supermarket refrigeration systems will fail. The checkout systems will go on strike. Even the electric. Security doors won't open. Either the blackout will only last for a couple of hours, or, even worse, it'll take days or weeks to end. At the beginning of the solar event, mankind will be lucky if there are only isolated accidents. The oceans could have ships collide, and airplanes could get lost. Electricity for the power grid, as well as all communication and radio networks, would have collapsed. But a massive solar storm that cheap fuel cards it could be triggered by at any time, any day, sounds like the script of a science fiction movie. This is a looming shadow that hangs almost nobody notices. The sun scientists watch the sun around. The clock, in order to give us a heads up if needed, But when the storm breaks loose, your warning only takes 10 minutes or 1 hour to reach us. Can solar research save us? The sun is a giant and incomprehensible force, powerful, dynamic, and through more than 4 billion years the center of the solar system. Where the light and heat come from, that makes life on Earth possible, and interesting in its own right. Breathtakingly beautiful but also utterly dangerous, these are constant flux upheavals of gigantic proportions and impressive storms. Sunspots, also the most striking phenomena, are dark areas on the surface of the sun. The sun's turbulent magnetic activity has left these areas very much cooler than their surroundings. These spots have a cycle about 11 years. During the peak, the so-called solar maximum, sunspots occur in greater numbers, and the sunspot region is in greater activity. Yet solar flares, like the sunspot cycle, are now thought to be relatively well understood, and in fact, quite easy to predict. Even then, things happen that shock our researchers completely unpredictably. But the sun is vulnerable to sudden increases in radiation and the release of huge amounts of magnetic energy. From time to time, coronal mass ejections periodically blast out huge amounts of plasma into space. By and large, none of this is any of our business. We see the big yellow ball up there glowing like nothing has happened. But only when we use special telescopes is the violence and the beauty of the fireball revealed. UV radiation can burn our skin too, damage plants, and scorch the soil. But in spring, we can luxuriate in the warmth of the first rays of sunshine, blossom in summer, live in beautiful auroras, or just be thankful. Solar activity is always unpredictable in many ways. They know general phases of the known cycles, although predicting the exact timing and intensity of individual events, in particular flares and coronal mass ejections, has proved to be hard. In addition, we don't yet know if there are other sun cycles that we aren't yet aware of. The solar storm of 1859 could be part of a cycle in which massive ejections are common every couple of hundred years or so, and violent ones could occur in millennia. In 1859, astronomers first recognized that a solar activity blackout event would happen in the middle of a solar storm. In fact, humans probably never noticed these natural spectacles before then because nobody used electricity. Again, we prove how small and irrelevant we are on the scale of our star by its unpredictability. What if even our sun is a pretty small bit of star stuff in a universe of billions of stars, many of them up to millions of times much bigger and stronger than our sun? The fact that we will need to study solar activity and cycles is crucial to our survival. What can NASA's SDO tell us about the news? The Solar Dynamics Observatory, SDO, built by NASA, is a breakthrough space telescope, intended solely to observe the sun. Since its launch in February 2010, the SDO has ushered in a completely new era in solar research. The observatory provides us with unprecedented insight into the dynamical processes on the sun, thanks to state-of-the-art filter technologies. Clearly, the mission's aim is to perfect our understanding of the sun and its effects on the Earth and near-space environment. The SDO is part of NASA's Living with a Star program, an ongoing effort to probe the Sun-Earth connection and study the causes of the complex geomagnetic storms that continually influence life and society on Earth. The observatory, which also works with a variety of sophisticated instruments that view the sun at different wavelengths, has to do this. The Atmospheric Imaging Assembly, AIA, captures images of the sun's atmosphere, or the region of material around the sun's visible surface here, through various wavelengths of ultraviolet light. These images are critical in the study of the dynamics of the solar corona, sunspots, flares, coronal mass ejections, and have been extremely important in the development of our understanding of the mechanisms responsible. The details of the storm only come into focus where there's filtering leading up to them, and a storm that would annihilate us is just chump change to the sun. The Extreme Ultraviolet Variability Experiment, EVE, is the world's most modern solar observatory and measures ultraviolet radiation from the sun. However, this data is very important for understanding the Sun's influence of our atmosphere and the Earth's climate. In turn, the helioseismic and magnetic imager studies the surface movements and magnetic field of the Sun, which are essential components to determine how the Sun moves internally and reacts to magnetic activity. One of the most remarkable features of the SDO is that it can send data out near real time. This decent data transmission rate means we get an entire picture of the Sun and what it's happening at all times, every 12 seconds. Real-time transmission can be very beneficial in an emergency. It's time to remember that a solar storm can only take 10 minutes to come to us. The SDO will give us a lot of new data, all which will significantly improve our knowledge and prediction of future solar storms. It will hopefully allow us to protect our satellites, communication systems, and power grids much better in the future. Currently, with NASA's Parker Solar Probe, the second hope of mankind is. Designed for close study of the Sun, this is a groundbreaking space observatory. Lifted off on August 12, 2018, the probe was named after astrophysicist and solar pioneer Eugene Parker and has periodically approached our star up until now to study it in detail. To the best of our knowledge, this is the closest probe ever to the Sun. The corona is one star up from which the Parker Solar Probe is going to study, and it's basically the combined outer atmosphere of the Sun. There, it will collect data to answer 3 fundamental questions of solar physics. But why is the corona hotter than the surface of the Sun? The temperature in the photosphere, the part of the Sun's surface, is about 55,000 degrees. In the corona, temperatures of several million degrees are thought to be common. The coronal heating problem is one of the greatest mysteries in solar research and is well known in astrophysics as this phenomenon. But the second question we have to answer urgently is, what drives the solar vortex in the first place? When the solar wind, the flow of charged particles released from the Sun, is accelerated through the entire solar system. Understanding how it does this will benefit from the science the Parker Solar Probe will provide. We will finally get answers for how solar flares and coronal mass ejections are formed. These powerful eruptions can be potentially dangerous for Earth. At these times, the Sun pumps out more particle fluxes into space than normal, up to 1,000 times. Neither the SDO nor the Parker Solar Probe can actively protect us. But that knowledge will help us do better in the future. There's a lot for power companies, communications companies, and technicians to learn about the Sun and its radiation. To protect our communications equipment and withstand huge amounts of radiation, we need to design power grids that can. There are so many great videos coming, and it's the best channel. Subscribe now.